So for our first example, here's our research question. Is there a difference in the blood albumin level of Hispanic dialysis patients from the normal healthy population? Our dependent variable is blood albumin level, which is on a scale. And for this research question, the population mean or specified constant, we're going to use the test value of 4.5. Now, I'm quite aware that blood albumin levels have a normal range, but for this example, we're just going to use the specified constant of 4.5. For these SPSS examples, I'm using actual real data. So to run the one sample t-test, you launch your SPSS, you go to Analyze, just like we do for most of our tests. We use the drop-down menu for descriptive statistics, and we cut across to frequencies. And this right here is going to, this is how we're going to check our two assumptions. So the frequency box opens up. In the variables box, I'm going to transfer across my variable, which is for albumin. We're going to keep the displayed frequencies tables, the little check mark at the lower left-hand corner. I believe it's up by default. Then on the right-hand side, we'll click the radio button for charts. We'll select histogram and show normal curve. And then we'll click continue, and then we're going to click OK. And SPSS will produce a couple of tables and then also a histogram for us. Now, the histogram is, you use histograms for continuous variables for which the albumin level is. And we can actually see that we've got a pretty normal distribution. It's got the little bell curve in it. You can actually see that it's high in the middle. One thing to note, on the far right corner, just about 10.5 and 12.2, we actually have a couple of outliers in our data set here. I'm going to leave the outliers in. I'm not going to remove them just for this example for simplicity. Also, too, I'm going to leave them behind because if you look in the upper right-hand corner, you'll see that the mean value is 3.03 with a standard deviation of 0.962, but my sample size is 815. So I've got a rather large sample size here, so I'm going to go ahead and leave my outliers in there because it's not really going to affect too much of my analysis. Going on, so to actually run the analysis, we go in SPSS, we go back to Analyze. This time we use the drop-down menu to compare means with the sidebar menu of one sample t-test. The test variable I'm going to move across is my albumin, and then the test value box, which is just above the radio button for cancel, is where I'm going to put in the value of 4.5. So now SPSS is going to compare the confidence interval of my sample against that test value of 4.5. We're going to click the radio button Options. We're going to ensure that the confidence interval percentage is 95% because that's what I want to use for this analysis. 95% is generally up there by default, but if you wanted to use a different confidence interval, you would change it here. We now click Continue, and then OK, and then SPSS once again puts out a number of tables. There's two tables that we're interested in. The first one is the one sample statistics, and where you can actually see the variable albumin, my sample size of 815. We get a mean value of 3.02, or actually 3.03, the standard deviation of 0.962, or actually 96199, and then we have the standard error of the mean. And then we have the one sample test. And as you can see in the top bar, it says our test value of 4.5, so you know what you're comparing against. The variable is on the far left, the albumin. We have a t-statistic of 43.74. The degrees of freedom is 814. This is a two-tail analysis, and we have on the sig value of it shows it as 0.000, so we know that the result is significant. We see the mean difference. Remember, this is the mean difference from the test value, which is negative 1.47391, and then we have a confidence interval of this mean difference. The lower is negative 1.54, and the upper is negative 1.4078. As you can see, the confidence interval does not include the value of 0. Thus, our results are statistically significant, which is shown in the sig value. And so how to write this up. So here's an example of an APA style write-up. So the result of the one-sample t-test showed that the mean albumin level of Hispanic dialysis patients, mean equal 3.03, standard deviation 0.96, was statistically significant at the 0.05 level of significance, where we have our t-value equaling negative 43.74, degrees of freedom 814, p less than 0.001, from the test value of 4.5, the mean difference negative 1.47, with the 95% confidence interval of negative 1.54 to negative 1.41. The null hypothesis, which suggested that there was no significant difference in the mean albumin level of Hispanic dialysis patients, is rejected. So that was our first example.